10 giây nhé. Hello everyone and Mr. Tran Hung. Let me introduce myself and my partner. My name is Hiếu and next to me is Đức Anh, Tuấn and Phúc. Today I'd like to talk about two common issues in library, why librarians often feel exhausted managing the library, and why readers tend to forget the book they borrow and end up getting overdue warning. Firstly, librarians get exhausted because managing a library is not just about shelving books. It involves organizing thousands of books, helping readers find information, and maintaining records. It's a job that demands both mental and physical effort day after day. And secondly, readers often forget the book they borrow because many are busy and may not have a habit of keeping track. Without a reminder or a simple tracking system, it's easy to overlook due date, especially if they borrow multiple books. It's a big problem. This result in overdue notice and frustration for both the reader and the librarian. And that is the reason why we stand here to tell you about our project, Library Management System. This simplifies the process of borrowing, returning, and tracking book, making it easier for both reader and librarian. So any project always needs a deep analysis and system requirement, and so do we. First, with a non-functional requirement, this refers to how the system performs rather than what it does. In our case, the system must have a strong database performance to ensure fast access and smooth handling of large volume of data. Security is also a top priority to protect user information and prevent unauthorized access. Finally, the system should have an interactive interface that is user-friendly for both users. Next, we have the functional requirement, which define the system main feature. This includes 4 kinds of management, which ensure that books are well organized, readers are properly registered, and borrowing activity are accurately tracked. Lastly, let's talk about system analysis. This step identifies the different type of user, like reader, librarian, and report user. It also explains how data flow and connect between various modules of the system, ensuring that all components work together efficiently. So next to me, Tuấn will talk about the database design and implementation.
And in these sections, the entity relationship diagram is the first thing we have conversation about. The ER diagram define 8 key entities. The entity books will be the central entity storing book metadata. The authors store author details. Category define categories or genres. For classification, the readers represent library member who borrow books. The staff, employees involved in lending and returns. The borrowing logs each borrowing transactions, and book author and book category are two bridge table connecting book with authors and book with categories. Next slide. And move on to ER schema. And we can see some prominent feature here. We can see that the relationship between books and author is many-to-many relationships. So there will be a central, a bridge table named book author, and the same situation happen with books and category with book category. And in the borrowing table, we see that it would take 4 foreign key, but actually from 3 tables, reader ID from readers, book ID from books, borrowing staff, and return staff ID from staff. Next slide. And the question is, how does this database work? In this database, When a new book is added, its details are stored in the books table. If the book has multiple authors or belong to multiple categories, the relationships are established through the book author and book categories table. When a reader borrows books, the system logs this transaction in the borrowing table, capturing the book ID, the reader ID, the staff member who processed the borrowing, which means the borrowing staff ID, and possibly the borrowing and return dates. If a different staff member handle the return, the ID is recorded in the return staff ID field. This field ensures that all the lending activity are traceable and accountable. And next slide. And this is our sample data of the database, my tiny library. And we can see the table books here. We store book ID in the primary key, the book names, published year, and quantity. The authors table will store author ID and 8 author name. The categories will store category. The table book author will store book ID and author ID because this is a bridge table, and the table book category with the same situations also store two ID. The table reader will store reader ID, reader name, address, and the phone number. And the table staff with staff ID, staff name, position, and way to contact the staff on phone number and email. And last but not least, the table borrowing will store borrow ID, the date member borrow or return the and foreign key, reader ID, book ID, borrow staff ID, and return staff ID. And next to me, my comrade will talk about the advanced database object.
Now my turn. Now I'd like to briefly present our work on index and view implementation for optimizing the performance and usability of my tiny database. To improve query performance, we implement index on frequently searched column. For example, in the book table, we create index on a book name and published year to speed up search by title and publication year. The author category and reader table include index to enhance name-based lookup. In the borrowing table, index like the return date and a composite index on reader ID and book ID optimize common query for borrowing record and currently borrowed book. We also create a view called view borrowing history using the create or replace view statement. This view combines data from multiple tables into a single readable structure. Next to me, Phúc will talk about the store procedure.
Now we will move on to store procedures. In our library management system, we use store procedures to efficiently manage core operations such as borrowing, returning, retrieving information, and reporting. The procedure enhance data consistency, streamline workflows, and boost system performance. The borrow book procedure handle borrowing requests. It checks if the book exists and has available copies. If not, it returns a relevant message. If available, it decreases the quantity, records the transaction, and returns borrowing successful. The return book procedures process returns by updating the return date and increasing the book's quantity. It confirms successful processing with return process successful. Next slide. The overdue report procedures. List book borrowed for over 30 days, whether returned late or still unreturned. Destroy the borrowing readers the book table to return details like borrow ID, reader name, book name, borrow date, and return date. Other procedures support data retrieval. Get all books, return basic book info, get book by ID, and get reader by ID, return full details based on given IDs. Get borrowings of reader ID and get borrowings of book ID, list all borrowings for a reader or a book. Get currently borrowed books, list unreturned books with related reader or and book info. Together, these procedures provide a solid backend for managing and analyzing library data efficiently. Next, Tuan, we talk about user-defined functions.
And about the user-defined functions, this will work like a function in Python that we learned before, and the user-defined function will simplify the complex queries into callable functions and prepare display-friendly string for front-end reports. It also isolates business logic, allow consistent and centralized change. On the slide, we can see that this functions that you input read a book ID to get the book informations. We see the example that the ID of the book was 6, and so it will return the name, Sherlock Holmes, the year, authors, and also the quantities. And next to me, then we talk about the triggers.
So for triggers, we have created some important triggers to have our database run more efficiently and enhance the database performance. The first trigger in our library system is called before borrowing update. Its main purpose is to check the availability of a book and update the quantity after the book is borrowed. To explain the realistic situation of this trigger, when a reader wants to borrow a book, the system first checks the quantity of the book. If the quantity is 0, the reader cannot borrow the book. Otherwise, if the quantity is greater than 0, book is borrowed successfully and the quantity will be reduced by 1. The next trigger of our library system is called after returning. This trigger automatically increases the book's quantity by 1 when 2 conditions are met. The first condition is the return date is updated from exchange updated from noon, and the second one is the return start ID is set. This means a book is officially returned and added back to the library stock. Another trigger of our library system is check borrow limit. This third trigger is based on a library rule that a reader can borrow a maximum of 5 books at the same time. This trigger checks how many unreturned books a reader has, and if the reader already has 5 books that haven't been returned yet, they are not allowed to borrow more unreturned. Also created some other triggers like insert, delete, and update books to add new books, remove old books, and modify the information of the books in our library. And to support this trigger, we created a table book logs to keep track all the changes by these triggers. So therefore, all modifications made by the trigger will be recorded in the log, and this allows librarians to easily track the history of each book at any time. So that's about our advanced database object. And now we move to database security and administration.
To ensure secure operation of our library management system, we have implemented several data security strategies, including asset control, encryption, auditing, and recovery. We use roles-based access control to manage use privilege. The read user account has read-only access to key tables. The staff user account has full permissions for system management, and the report user has read-only access for reporting. This structure enforces least privileged access and supports secure operations through the Streamlit interface. A password expiration policy further enhance security. Read user password expire every 90 days, while internal account start user and report user expire every 180 days, reducing long-term credential risk. To prevent data loss, we use MySQL dump for full database backups, which can be restored quickly using the MySQL clients. SSL TLS encryption secures data transmission, especially during remote access. We also implement auditing and monitoring to check database activities and support incident response. Lastly, file level protection ensure only authorized users can access or modify database files. Together, these measures provide a comprehensive and effective approach to database security. Now, Đức will talk about the next part.
About optimizing database performance. In this part, we focus on analyze the performance of store procedures, triggers, and user-defined functions. Our method is using explain queries to evaluate, select, update, and insert queries in these database objects. This will analyze the access types, row scan, and index usage, as well in order to pinpoint the bottlenecks like full table scan to improve it. However, our result that we receive that or queries in our database objects are already optimized well with the current database. So next, we'll move to the next part, which is database Python application.
So let me tell you about the data management purpose and benefit. The main purpose of our data management module is to simplify user interaction with the database using a Python interface. This module allows us to execute store procedure to handle borrowing and returning transaction, and to retrieve and display data such as book, return, borrowing record, and overdue report. We must ensure for discipline, simplify database iteration, ensure robust error handling and connection management, provide a flexible interface for testing and integrating with front-end application, and the last, support real-time data retrieval and transaction processing for library operation. We have implemented several important functions. The first, connect to DB, we establish a secure connection to the MySQL database. The next, borrow book, we call borrow book and store procedure to process borrowing. The function return book execute the return book store procedure for book return. The function call procedure to call any procedure and retrieve data used for tasks like generating report and listing available book. We also have a test script to demonstrate and validate the usage of the function with the sample data we mentioned above. Now, Tuân, we talk about the library and query.
And before we start operate the code from these sections, we have to import two important library to create engines. That's SQL Alchemy and Pandas. And on the biggest picture you see on the slide in this script is set up a connection to the database my tiny library using SQL Alchemy, ensure that my SQL is running and the required tables are exist. On the query start category is the query to make a statistic analyzing on the category. Based on it, the time is of the book has that category borrowed, and we can see the result in two two ways, on the prompt or on the Excel file, and exclude when it include an Excel file, and we can use it as a report material. And next to me, my comrade will talk about the interactive interface.
So to make our system more interactive, we use Streamlit to build a simple website for our library system. There are three types of users in our system, which are readers, staff, and reporters. When logging in the system, user will have to enter the username and password that are provided by the library system according to their role. So this is the login interface of our library system, and the main interface when you have logging in will look like this. With the interface is divided into two parts. On the right hand side there is a select list for user to choose the function they want, and on the left hand side the interface will display the selected function contents. Although the interface looks similar for all users, the permissions are different. As a reader, user can only view information such as available books or their borrowing history. Meanwhile, on the next slide, we'll show a staff member can perform actions like borrowing books or returning books, as well as showing the overdue report, as they monitor the library system, so they are the editor of the library system. And finally, another user is reporter, who focuses on generating reports about overdue returns or currently borrowing books. So that's about our interactive interface. And next we'll come to result and evaluation.
The library management system has been successfully developed with the following main components: complete database with tables, views, procedures, and triggers; Streamlit app for managing books, readers, borrowing, returning, and reports; role-based access, clearly defined permissions for staff and admin. The system is evaluated based on the following criteria: requirement fulfillment, fully meets both functional and non-functional requirements. About performance, basic queries less than 1 second, complex reports less than 3 seconds. Streamlit load in 2 to 3 seconds, ensuring smooth use. About user experience, interface is intuitive and easy to use. No technical knowledge required. Positive feedback from trial users. During development, the system encountered several limitations and challenges. About technical issues, foreign key errors encountered during development, and performance not optimized for large database. Missing features such as no automatic notification for overdue books and no advanced analytics. Anyway, we'll talk about the last part.
And finally, we'll come to some recommendation for our data for our project. First of all, if we have more time, we'll do this. We will split the borrowing table. This will really helpful for large-scale libraries like 1,000 million of transactions per month. Another recommendation for our project is do the flexible loan periods by adding a borrow time field to support custom duration by book category or user extension. This will also require updates to store procedure and trigger as well. Another important recommendation for our project is using multi-branch support by introducing branch table, and the library ID will be added to relevant tables to create an inventory table to link books with branches. Moreover, we also have some other recommendation for better result of our project, such as adding email alerts for due dates creating real-time dashboard to visualize usage trends, automating report generation via other apps like Scrum or Task Scheduler, implementing error logging, input validation, and role-based access, using QR code for faster error-free transactions, securing credential via environment variables and limited database roles, migrating to cloud database for remote access, backup, and branch scenes. So if you are a big fan of reading book and wants to share this blog to other people through a library, it's great to collaborate with us because we will continue developing our library system in the near future. So that's all about our presentation, and thanks for listening.
Thank you, everyone, listening. That's the end of our project.